Okay, here are some of the questions that that were asked during class today. So it says between the graph of f of x is equal to x squared minus 2x minus 3 and the x-axis and the line x equals negative 1 and 4. So let's graph that first. Let's see. So the line x equals negative 1, so this line here. And then 1, 2, 3, 4. That line there, that's a boundary. And then we have this function x squared minus 2x minus 3. Let's factor this. X minus 3 and then x plus 1. So I know the roots are here at x equals negative 1 and at 3. And I know the a value, the leading coefficient, is positive, so it's going to open up. I'm not trying to be really accurate here. I'm just trying to show you what it looks like. So let me change the color, maybe. So something like that. So we want to know the area here and here. And notice that from negative 1 to 3, this is below the x-axis, and from 3 to 4, it's above. But we want to know the area between the curve and the x-axis, and then these boundaries. So we're going to find the positive area. Okay. So here, negative 1 to 3, and x squared minus 2x minus 3 dx. And I want to find the absolute value of this because this area is under the x-axis and it's going to be negative. So plus, from 3 to 4, the same function. Okay? Here's a setup, and now I just have to find the integral. All right. Let's change colors to blue, and then x cubed over 3 minus x squared minus 3x from negative 1 to 3. And of course, you want to find the absolute value of these. And the same function from 3 to 4. Okay, this one's going to be positive, so I don't have to worry about that. All right. So let's plug in the values. If I plug in 3 in this function, I get 3 cubed divided by 3, so it's 9. Minus 9. Minus 9. Minus, when I plug in negative 1, it's negative 1/3. Minus 1 plus 3. And I want the absolute value of this. Plus, if I were to plug in 4, I would get 64 over 3 minus 16 minus 12 minus, and I'm going to plug in 3 here, which is exactly the same as this. That's negative 9. Okay, so that's the absolute value of negative 9 minus, this is going to be 2 minus 1/3, so 5 over 3, plus, that's going to be negative 28 plus 9. So 64 over 3 minus negative 19, negative 28 plus 9 times 3. Okay, negative 57 over 3. There you go. And this is going to be positive, so let's make everything over 3. And that will give us negative 32 over 3, but then that's going to be positive, right? Plus 64 over 3 minus 57 over 3 at the end, and that's going to be 96. So 39 over 3, which is 13. Okay. I'm not quite sure why you're asking this question because the answer key is pretty clear on this. Maybe the handwriting was kind of bad, so you couldn't see, what the numbers were. But I thought it was pretty straightforward. You just want the area between the curves. So in this case, you ignore the negative signs and make it positive. Another alternative would be instead of putting the absolute value sign, you can put the negative here, and that'll make it positive as well. This is the second one, 1e. Again, this was pretty clear on the answer key, but let's look at this. Let's graph it first. Alright, since it's 3 cosine of 2x, the amplitude is 3, and then the b value of 2 means instead of going to 2 pi to finish one revolution, I can go to pi, right? The complete revolution finishes up at pi, and it's pi over 2. So you would start at 3, here's negative 3, and then there's pi over 4, and 3 pi over 4, uh-oh, I said 4. 3 pi over 4, so here, and then here, here, and here. So my function looks like this. Okay, so we are trying to find the area between the curve and the x-axis and the y-axis, and then x equals pi. So here, here, and so we want this area here, there, and that. What's nice about this is that if you look at cosine curve, this section right here is the same as this area here, which is the same as this area here, and lastly this area here. So they are all the same area. So instead of going through setting up 3 different integrals from 0 to pi over 4, pi over 4 to 3 pi over 4, and 3 pi over 4 to pi, I'm just going to find the area of this one section from 0 to pi over 4 and multiply that by 4. Okay, that's going to give me the same area as doing 3 different integrals. So I'm going to do 4 times integral from 0 to pi over 4 of 3 cosine of 2x dx. Okay, so what is that going to be? Well, it's going to be 4 times, right? 3 over 2 sine of 2x. And then from 0 to pi over 4. Okay, and then let's see. If I plug in pi over 4 here, that's going to be sine of pi over 2. So 4 times 3 over 2 sine of pi over 2 minus 3 over 2 sine of 0. And I know the sine of 0 is 0. That's gone. And sine of pi over 2, remember, sine of this is pi over 2 here, so that's going to be 1. And at the end, the answer is going to be 4 times 3 over 2, which is 6. Okay, so the area between the curve and the x-axis from 0 to pi is going to be 6. And lastly, the area between the x-axis and this function here between 1 and some unknown value of a is 45. Find a. Okay, so I think what you're confused about, because everything else was pretty clear, is how to change this function into whatever they had. And f of x, and I'm going to separate these two functions into two fractions. Okay, and it's pretty clear that this first part is going to be 1. And then you can either try to rationalize the denominator, or you can think of this as x to the negative 1/2 when you move up. Either way, you're going to get 6x to the 1/2. Right? So you can think, okay, well, let's try it this way then. That's going to be x, which will cancel out with that right there, and 6 squared of x, which is 6x to the 1/2. Or you can think of it as, okay, 6x over square root of x is 6x times x to the negative 1/2, which will again give you 6x to the 1/2. Okay, so f of x is this. So if you say, okay, integral from 1 to a of this thing is 45. So what is a? Then I can say, okay, x plus x to the 3 over 2, then multiply by 2 over 3, so it's going to be 4. From 1 to a is 45. And then a plus 4a to the 3 over 2 minus 1 plus 4 is 45. And okay, a plus 4a to the 3 over 2 is 50, and you can't solve this, so you got to use your calculator. What I would do is in y1 type in a plus, or x I guess, in your calculator. In y1 I would type in x plus x 4x to the 3 over 2 minus 50, and then y2 is equal to 0, and find intersection, and you're going to get 5.1 something, 5.0. Let's find it. 5.0193. And if you round it up to 3 significant figures, you would get a is equal to 5.02. So you can check your answers by plugging in 5.02 here and putting this into a calculator to see if you get something close to 45. It should be really close. Bye.